In this video, I'm going to show you how to graph quadratics in vertex form. And the way that that's going to look, let's just write it first. Graphing quadratics. And we're talking about vertex form. It's not often that you will see quadratics in this form, but if you do see them in this form, it is definitely a lot easier to graph. It's one of the easier forms to graph in. So the generic version of this equation will look like this. And that reads y equals a times the quantity of x minus h squared plus k. So a will have a number, h will be a number, k will be a number, and y and x will stay as letters. So we can get into it in just a second here. Remember, a little review. A is kind of a slope, but in quadratics you have a parabola, which is going to have a curved slope. So the slope isn't necessarily going to be very helpful. But remember, if a is positive, or if a is greater than 0, then the parabola is going to open up like a cup. And if a is negative or less than 0, it's going to open down like an umbrella. So that's always a good check. If you see your equation, just think about that, just so you're graphing things correctly. Also in this form, h and k are going to be helpful. This is why this is called vertex form, because the vertex is actually whatever value k is, for sure. That whatever value this is, if it's positive it goes there, if it's negative it goes there. Just right there, it's going to be your y value of your vertex. But h is a little trickier. H is the x value, but h isn't going to include the sign that's in front of it necessarily. So if we were to have a 3 right here, so that it said x minus 3, we'd write a positive 3 here. So the way you can think about it is whatever h looks like right here, the vertex coordinates are going to be the opposite of h. So that's the way I like to think about it. It makes it a little bit easier, even though it's kind of tricky to think about. So let's do some examples and see if it makes sense here. Let me get my graph going here. Alright, so our first example, let's try y equals 2 times x minus 1 squared plus 3. Excuse me. So, again, look at a. Is a positive? Yeah, so we're going to have a parabola that opens up, and the vertex, the tip of that parabola, or the very lowest point of it, is going to be the coordinates, definitely 3, that's going to be our y value, positive 3. The h right here is going to be the opposite of whatever it looks like. So it looks like it's negative 1, so the h value is going to be positive 1. And that's our x and our y coordinates of the vertex. So the very tip right there is going to be at 1, 3. So let's graph it at 1, 3. Let's put a tip there. And we know our parabola is going to do something like this. It's going to open up, that being the tip. So to complete your parabola, use the good old xy table. And the trick here is to use values for x that make this whole thing really easy to solve. So if you plug in 1, then the whole thing becomes 0. 1 minus 1 is 0, 0 squared is 0, and 2 times 0 is 0. So this whole front part just goes away, and we're left with y equals 3. So if x equals 1, y is 3. So let's try and make other values that easy. And since you know that this right here is our line of symmetry, then it's going to be reflective symmetrically across that line. So you can either use values to the right, x values to the right. So if we start at 1 for the x, then our next value would be 2 and 3 and 4. We would use our table to figure that out. I think in this case going to the left would be easier. So I'm going to use 0 for my x value, because that makes this really easy to solve. 0 minus 1 is negative 1. Negative 1 squared is positive 1. And 2 times positive 1 is 2. And 2 plus 3 is 5. So at 0, 5, there's a point on our parabola, and we know it's symmetrical, so we know that if we plugged in 2, we would get 5 just the same. And let's try and use one more, see if we can fit another dot on there. So I'm going to keep going left. I'm going to try -1, see if that's easy to do. Well, -1 minus 1 is -2. -2 squared is +4. +4 times 2 is 8, and 8 plus 3 is 11. So we're going to be slightly off the graph when we keep moving. So we can put that there. Connect our points, and there we graphed the parabola of this equation, this quadratic equation right here. Let's do another example. So we're going to see some slight variations coming up here. It's the opposite of the quantity x. I think it's supposed to be +5 squared plus 2. So again, right here, a is a -1. That's just implied. So we know we're going to have an upside down parabola, an umbrella. And we know the vertex, that tip right there, is going to be at the opposite of h. So if it's +5 there, the vertex coordinate is going to be -5 for the x value. And k is a +2, well, it stays +2. So that's our vertex, -5, +2. So it's going to look something like this now. Alright, again, xy table to figure out the rest of our parabola. And you want to use values for x that make this very easy to solve. So you can keep going left on the x-axis and use -6, and that might be pretty easy to do. Or you could hop over here and use -4. I think the smaller the numbers, I mean, it's not a huge difference in this problem, but always try and do the easier one. So that's going to give us -4 for x, so -4 plus 5 is +1. +1 squared is 1. And 1 times -1 on the outside there is -1. And -1 plus 2 is +1. So at -4, the y value is going to be at 1. Again, this is our line of symmetry, so we know that point is going to be right there as well. Let's keep moving. Let's go -3. And see what that does. So -3 plus 5 is +2. +2 squared is 4. 4 times -1 is -4. -4 plus 2 is -2. So -3, -2, and -7, -2. And we could keep going, but that's enough to get the idea of our parabola there. So again, this is our vertex. It's always helpful when you're solving quadratics to find the vertex. Also, what's helpful is right here, right where that crosses the x-axis, that's called the x-intercept, right there, and right over here. So there's always, well, not always, usually with a parabola there's going to be 2 x-intercepts as long as it's crossing the x-axis. And we'll talk about problems that don't have x-intercepts coming up here real quick. And finding the x-intercepts where y equals 0, that's always where the x-axis lies. So if I was to plug in 0 for y and solve for x, I would get this number and I would get that number. I would get 2 values. And that's kind of crazy to think about at the moment, but hopefully in the future, the very near future, it makes sense. So always knowing the x-intercepts and the vertex is helpful information in dealing with problems that use quadratics, whether they're word problems or just graphing like we're doing right now. Let's do another example here. Alright, let's do y equals -1/2. And this is where choosing the right x value is going to be helpful. Alright, so again, think about a. Is it going to open up or down? Well, a is negative, so we're going to open down. It's going to be a fatter graph. 4 is going to be our k, so we know our vertex y coordinate is going to be 4. And again, This looks like a positive 3, so the x value of the vertex is going to be the opposite of that. It's going to be negative 3. So this is our vertex. Let's plot it. Negative 3, positive 4. And it's going to open down. So when we do our xy table here, let's make sure it's actually going down. So again, use values for x that make this easy to do. If I end up getting an odd number out of this expression right here, then taking a half of that is going to be a decimal, and then it starts to get crazy. So we always want to do something that comes out of this expression that is even, so that way you can take a half of it really easily. So I'm going to use -1 first. Let's try that. So if I plug in -1 for x, I get positive 2, and then if I square that, I get positive 4. And if I take a negative half of that, that's negative 2, and negative 2 plus 4 is positive 2. So -1, 2, it's going to be on the parabola, and it's going to be symmetrical across that y coordinate right there, or x coordinate, sorry, -3. So this was 2 over and 2 down, so the symmetrical point would be 2 to the left and 2 down, right there. And again, choose another value that makes this easy to solve. Well, -1 was pretty easy. Let's try positive 1. That'll give us 4 here. 1 plus 3 is 4. 4 squared is 16. The negative half of 16 is -8. And -8 plus 4 is a -4. So at positive 1, -4 is another value on the parabola. Again, it's symmetrical. So it was 2 over from that point, and then 6 down. So 2 to the left and 6 down would be right here. And then that's enough to draw a parabola there. So right there. So again, here's our x-intercepts. There's going to be 2 of them, one there, and one right there, and our vertex is up at the top. All things that are helpful in solving quadratics. Alright, so that is graphing in vertex form. And again, it's nice because if you know where to look in your equation, it gives you the vertex of the parabola. And then from there on, all you got to do is just plot points in your xy table, and you get a nice parabola out of it. Alright, we got one more form to talk about. That'll happen in the next video.